So, good evening. So today is our last day, and total, I think, 12 weeks course. Yes, this one. It's the last week, but we had an extra session with mostly routine on the microgrid aspects. So today we would be discussing a bit of the other aspects like the distribution system automation, role of integration of DERs, how the wind integration, PV integration, or battery energy storage system integration helps the system operation in a better manner. So all these things will uh, try to cover. And and lastly, we would be going through the assignments, last to last assignments, previous uh, assignments that were being given as a part of this course. And I think some assignment questions from the last day also. And questions related to battery storage systems as well as wind energy systems, uh, PV integration also some questions are related. So we will do more of questions today. But before that, brief insights of I think in the last week or in the last class taken by the other TA. So you had an overview of how the distribution system automation works. Although I think this week's part covers mostly the renewable integration, DER integration, like how the wind works, how solar works, and how energy storage works, fuel cell also everything we are discussed. So that because the thing is that as we are moving up towards the application perspective. So when all these things get integrated, the system operation becomes much more complex, right? And to address this complexity, like the distribution system automation, so as we are in a era of smart grid, the conventional term smart grid, as Sir has also said in his lecture, that the smart grid itself is a new term, so not a proper definition is available, but based on overall definitions that he has delivered in his lecture series, so he has given a brief or very nice detail of how and why the need of smart grid is there and why it is called smart grid, because of the integration of the information over the operations that were previously there. So things are becoming smart. For this, the communication systems needs to be developed in a better manner. And nowadays, systems with hybrid, we so as we let's discuss a bit of the distribution system automation. What are the major equipments? As Sir has already told, from the point of view of distribution system automation, we have SCADA systems where the RTUs, IEDs, all these communicate the data to the control center, and based on the series of actions that are detailed in the SCADA, so based on that, the control or the operator takes necessary actions, right? So, so mainly to facilitate a better control or operation, these things are getting integrated day by day, and we are in a stage where we are facing the transition, right? So in some of part of my work, in which at least I try to work there, what I try to emphasize is to work on the hybrid operational aspect, right? Where we have the in the practical in the distribution side, practically the data collecting devices are very less. Okay, so we need to emphasize more on the devices which are at least placed. So, but mostly our emphasis is given to the pseudo measurements. So, any idea what is pseudo measurements? Because to work or to understand the distribution system automation, DMS, distribution management system, or it is also known as ADMS. So we need to give a more emphasis on data collection system so that the various analysis can be performed. But we should have the data at priority. So this thing means this entity plays a very critical role or crucial role. So any idea what are pseudo measurements in the distribution side? I think Sir has given overview. We will move towards the question answer part, but if you have any idea, otherwise these measurements are the node load forecasts, right? So these are very much uncertain, pretty uncertain, because uh, these are forecasts based on the historical data available. So this data needs to be uh, refreshed or needs to be corrected on a larger scale to at least have an overall picture. So in the current time frame, as we are moving with various data collecting devices, one of the primary data collecting device, which is the smart meter, these are getting installed smart metering. So these are smart meters are getting installed in the customer premises, but how are these data being collected from the smart meters to the control centers via the communication protocols that are generally used? And but the problem is uh, what we know or what we understand is that with the massive integration of these DERs, in place in the distribution systems, we need to be much more accurate with performing the proper monitoring, which can be done using the state estimations aspects, right? So how the state estimation, this acts as a primary firewall. Okay. So based on the data collected, if we rely entirely on those data, so that would create a much ambiguous uh, state. Okay. In some cases, because of the measurement uncertainties which are prevalent in the measurements. Okay, and these measurement uncertainties can be due to the communication channel delays or communication channel issues. Okay, as well as the aging of the instruments, as well as the temperature functionalities, which have a great impact on these measuring instrument or measurement data. Okay, so in association with that, it has delays with it. So everything when gets accumulated, this leads to measurement uncertainty. So how far these uncertainties, there is another research domain which deals with quantification of these uncertainties in for all these type of meters, which takes a which takes a prime role in the current day distribution management system or distribution system automation and control. So the major aspect, we find out the state estimation outputs, which are the voltage magnitudes and phase angles. So previously also I have discussed the outputs of the state estimators are voltage magnitudes and phase angles. So, but before that, we need to have one of the uh, major I should say assumption is that the state estimators at least have uh, observability which is greater than 1. Okay. So what does it mean? That the numerical observability, when it is greater than 1, it signifies that the number of measurements should at least be greater than equal to, okay, should be greater than equal to number of states. Okay. So now here comes a question that what's the need of state estimation if we have the measurements altogether? So the need or necessity is that we are to uh, find out the proper operating states of the system. So there may be cases where we have, let's say, here we have one bus, here another bus, here. So let's suppose this is test case, not an exact practical one. Let's say this is the case where we have a generator here, loads are connected here, another generator here. So there are loads connected in each of these buses. Let's give the bus 1, 2, 3, 4, 5, 6. So all these are some are load buses, some are generator buses. Please consider this as the slack bus. So the thing is that here, what will be the number of states here? Any idea? Previous Sunday also I discussed. Okay. So the number of states, since V and delta for all the buses are the number of states here, right? So when we say V and delta, so here we can see that there are 5 buses except the slack bus. There are 5 buses. So V and delta would be the reference values, and the magnitude of the slack bus, since 0 is the reference angle, so 0 is not the state variable. So we have total of 10, 11 state variables. Okay. 11 state. So to at least monitor 11 states, we should have 11 measurements. So in the distribution system, these to have a better monitoring aspect in the form of distribution system automation, we have to have at least 11 or more, means 12, 13, 15, 20, anything else. There should be redundancy in the measurement, because if any measurement goes wrong, that would lead to improper estimate of the states. And since the entire thing, like optimal system operation, optimal distribution system operation, we may say the aspect where the generation control of the microgrid level, when we say about the microgrids, we may say about the distribution grids, renewables, the control actions which govern based on the outputs of the space, the input-output injection, as we have sometimes we try to store energy to the batteries if there is an excess from the renewables. So considering all these things, we need to have a good estimate of the states. For that, we need to have accurate measurements. But the measurements are totally concentrated. The measurements that we obtain directly are along with some uncertainties. So for that, we need to estimate the states. So we can't say that those measurements are accurate. So we can estimate the states. There can be situations where measurements are not placed in these buses. Let's say bus number 6. Here no measurement is placed. Here there is an absence of, let's say measurement is placed here, measurement is placed here, measurement is placed here. But since we have the Y-bus matrix of this entire grid or distribution, maybe transmission, so we can calculate or we can estimate based on the power flow equations or the power injection measurements, that can be calculated. Means these can be estimated based on the measurements available. But at least these measurements should deliver, if there is a SCADA, then or RTU we may say, it can deliver the measurements like voltage magnitude, power flows, means real power flows, reactive power flows, real power injections, reactive power injections. Okay. If we have a PMU, this is for the SCADA or the RTUs, from the RTU SCADA system. From the PMUs we get the voltage magnitude, phase angles, current phasors like the real, current, imaginary. Okay, so we can reconstruct based on if a measurement device can deliver multiple measurements. So an overall redundancy should be maintained. Okay, so based on that, from the output of the estimator, we can frame the distribution system control. The modern day distribution system control actions can be beneficially delivered to as a form of distribution system automation. Okay, so there can be situations where, but for all these things, we need to keep track of topology. Topology is a major concern since the renewables, with the renewable integration, topology of the grids are continuously varying. So considering all these things, meter readings, meter data collections, MDMS, meter data management systems. So all these things in the form of smart meters, in the form of micro PMUs, RTUs. So overall, this data collection system lays the major emphasis, lays the major foundation of the distribution system control and operation or control action. So the primary or the governing system is how data is collected from each of these systems, right? So from the smart meters, these are mostly in the residential side. So what we do is that we collect the aggregated smart meter data at the uh, transformer MV level, and perform MVSE, mean MV side state estimation, and accordingly we take the following control actions, right? So in the current context, a hybrid uh, metering facility is more uh, more obvious, because we can't discard all the types of measurements that are available in the current time frame and give total or replace the entire measurement sets entirely at the current time frame. So hybrid models of measurements with varying refresh rates, because if we consider the PMU can deliver data considering 1 second. In 1 second, PMU can deliver around 25 to 50 data. Again, in the form of RTUs or the SCADA system, it gives or delivers data. It can deliver data in seconds, but those many generally it is the data is collected in minutes, 1 minute or 5 minutes. Okay, 1 minute in one data. Now, or there can be situations where RTUs can deliver data in seconds. It is, let us say, from 2 to 4 seconds also. There are cases. But generally in the distribution side, uh, mostly the data is taken in 1 or 2 minutes. 1 or 2 minutes. Considering the smart meters, the data is generally collected in 5 to 15 minutes refresh rate. Although there can be situations when again the data can be collected in seconds range too. So in 1 second data can, but generally for the control or actions. But these entire set of real-time data, these are real-time data devices, right? So these real-time devices are very low in a distribution system. So what we need to rely on the pseudo measurements. As I previously said, that pseudo measurements are the node load forecast based on the previous year historical data. These data sets are prepared to at least perform state estimation in the medium voltage side, and then this forms the integral part of the, I should say, distribution management system or advanced distribution management system. Okay. So first, after performing the AC, the overall V and delta of all the nodes are obtained, and accordingly, what we do is that we perform the further activities, which may be in the form of loading scenario needs to be checked multiple times. Uh, what is the loading scenario at each conductor or each line? Okay. So all these things needs to be checked in practical aspect. So this forms the basis, and the remaining parts, control actions, control functions, all everything were discussed in the slide. So if you have any doubts, mostly I tried to emphasize on the part of the distribution system automation, which I should say, which is this is the critical part. Means after this, everything is done. So data collection and data security of the data is another aspect. So everything, the data that is obtained or delivered to the control center, how much the data is secured, or how much the data packet is secure from various types of attacks in the distribution system. Uh, so with the EV of the customers in the distribution side, in the market side, so there is a huge penetration of the customer level too to participate in these demand response activities. So substation automation is also a part. So everything integrating totally advanced distribution management system. So this was overall the idea that I tried to emphasize. So if you have any questions, you may ask, or we will switch on to the question answers. Okay, then let's start with the questions. So this is the first question. In a wind turbine, the efficiencies of gearbox and turbine generator set are 70% and 95% respectively, determining the maximum theoretical overall power consumption efficiency of the unit. So here this theoretical model power consumption conversion efficiency needs to be considered. Please try to solve and answer in the chat box also. It's an easy one. Please try to solve. A, A, why A? First of all, A is not correct, but why have you mentioned A? What is the calculation that you
0.7 into 0.95%
okay? But
combined efficiency.
that's why I have underlined this term theoretical overall power conversion efficiency. So, what is the maximum power conversion efficiency that can be obtained from the wind turbine?
59%.
Yes. So, all these 70 and 95 is okay, but before that, you need to take 59 into consideration. Right?
That is B, I think,
Yes,
39.2.
yes, B. Option B is correct. So, it will be so maximum efficiency is max into year into uh, generator 0.59 into 0.7 into 0.000. That would be 59. So B is correct. So next question. Solar panel operated 30 watt. 10 volt is to be used to supply a 240 volt single phase load of 2.88 kilowatt. How many panels will be required for this and the arrangement? Any answer? D. Yes, D is the right answer. D is the right answer. So, so 240 volt is given. So number of series panels for 240 volt. 240 volt is 240 and the rated voltage is 10. So 10 volt, 10 volt per panel. So the answer would be 24 here, 24 panels. Now the question is, as the load is given 2.88 kilowatt. So now comes the factor of current here. Okay. So current uh, delivered by each panel, I say each panel, that is power of the panel, or this is total of 30. Rated is 30 watt. So power per panel, I should say, by volt per panel. So 30 divided by volt per panel is 10, so 3 ampere. So in this manner, so total power that can be produced by 24 series panels, that will be 240 is the volt and 3 is the current. So 720 watt. So number of parallel paths. So our question, so number of panels we have obtained. 24 panels to form a path. Such that 4 parallel path is the option. So how the 4 parallel path, the total load to be delivered is given 2.88 kilowatt. That means 2880 watt. And power that can produce by 24 series is 720. So number of parallel paths 2880. So final answer is 24 series panels and 4 parallel paths. So this is one of the answer, and this is okay. I think it's clear for all. So moving on to this next question. Which one would have the highest generation? These are the cut-in speed, rated speed, and shutdown speed given. C. C is the correct because we all know this is the profile. This value is given, this value is given E, this value is given sorry, this value is given E, this value is given 55, and this is 50. So out of which it can max. So it can deliver the maximum value. So since the options, as per the options given, 45 would be somewhere here. So that will be the correct answer. Okay. So some theoretical questions are there now. We will. So the following four storage is having which of the following out of this following which of the storage is having the highest capacity in megawatt and energy storage megawatt hour. Okay. So lead acid battery, lithium ion battery, pump storage that is hydro and with high power flywheel. megawatt capacity and megawatt hour highest. Yes, pump storage is this is an MSQ question. So a fuel cell needs a hydrogen supply at the anode, a hydrogen supply at the cathode, oxygen or air supply at the anode, oxygen or air supply at the cathode. And D. So hydrogen supply at the yes. So which speed yes. So tip speed ratio of the wind turbine depends on wind speed, rotor radius, rotor speed and all of these. So optimal network configuration is a part of the following smart grid initiatives: substation automation, distribution management system, distribution system monitoring, or none of these. Optimal network configuration. Distribution management system. Yes, it is a part of distribution management system. This is an MSQ question. Uh, an implementation of automated metering infrastructure needs a smart meter, a unidirectional communication system, a bidirectional communication system. AC. Yes. Smart grid will enable efficient management of bidirectional power flow, bidirectional data flow, bidirectional flow of data and power both, and none of these. Hmm. SCADA includes so SCADA includes the master control station, sensors, analog to digital or digital to analog converters, bidirectional communication links, and all of these. All. This is a MHQ question. So, what are the main features of the power flow control strategy in energy management systems, peak load reduction, effective control and management, increase lifespan of the storage system. A and B, uh, yes, both are correct, but in addition to it, the increase the lifespan of the storage system is also correct. So all three are correct here because as a part of energy management system, when it is connected to the distribution grid or distribution side, so our aim is to also increase the lifespan of storage systems too by optimally using the resources or optimally delivering power as per the generation of the from the renewable source. So all three are correct. So So these are statement type questions. So statement A is a bidirectional DC-DC converter can connect PV panels to a conventional three-phase grid. And statement B is ultracapacitors are connected to DC microgrid using an AC-DC bidirectional converter. So statement A is true, B is false. Statement B is true, A is false. Both are true and both are false. So, yes, both are false. Both options are false. So renewable generation is of high interest nowadays due to increasing per capita energy consumption, deficiency of fossil fuels, both or none. Yes. Both. So identify the correct statement. So maximum solar power injection during off-peak load hours may result in under voltage condition. Peak hours with little or no solar power may result in under voltage conditions. Reverse power flow is not possible in the active distribution networks. All are correct. Here I reached peak load hours. B. Yes, B is correct. Uh, This is an MSQ question. So battery energy storage system has been proven to be an effective solution for voltage control, flattening of the load curve, reduction in the power losses. Is option B. Uh, E. Yes, A and B. But to some extent, reduction in the power losses can be considered too, because in the distribution side, batteries are connected in the mostly in the lower end, or maybe in the other LV side, NPLV or NB side nodes. So to some extent, if that amount of power would have been taken from the grid itself, so that would have resulted in much line losses compared to the power or the current, since the current flow would be uh, towards the load side itself, or we may say would be concentrated towards the load end. So the power loss that is of the current that needs to be transferred from the grid to the load, that can be minimized. So suppose if this is a substation and the loads are connected all throughout these nodes, these are, let's say, the nodes. And somewhere if the battery is connected here and to maintain a voltage profile, let's say this is a base. So that amount of power can be uh, controlled. So we may say that reduction in power losses too, but considering the fact that it will have some assumptions within itself, that the battery should not be placed towards the substation and more towards, since it's a practical consideration, it is generally placed in the load end, so that's why this may sound good too as an answer, possible answer, but yes, A and B are right. Question 16. So So what are the smart grid R&D areas under ICT and cybersecurity? So ICT is information and communication technology, right? And the options are seamless grid operation involving transmission and distribution system operators, TSOs or DSOs leadership, reliable wired and wireless communication, coordination and control of multiple inverters for all of these. Yes, but why D? The R&D areas under the aspect of ICT and cybersecurity, it has been clearly mentioned. So, uh, is D the correct option as per the area of R&D that has been mentioned? Yes, communication and reliability. Yes. So, AMI means advanced metering infrastructure. OMS means outage management system. PLM means peak load management. So, yes, primary goals of Indian smart grid pilot projects. Yes, he is the So the excess load demand in PV or wind integrated distribution systems result in voltage sag and reverse power flow, voltage rise and reverse power flow, voltage sag only or voltage rise only. A means voltage sag and reverse power flow. Yes. C. How reverse plus oh, yes, voltage sag only. So which of the following PV technologies has the highest efficiency? Amorphous silicon, copper indium gallium selenide, monocrystalline silicon, or polycrystalline silicon? Yes. So why is low speed shaft connected to the gearbox? To increase stability, to increase RPM, to decrease the stress, none of these. Any option? C. No, to decrease the stress. No, no. It's the low speed shaft is coming from the turbine or in the wind blades, right? So when the blades are connected to the shaft, here we have the gearbox. So this is the shaft. So outside of this gearbox, the speed increases, right? So this is low speed and this is high speed. So this has to rotate the uh, PFIG or PMSG model, anything, or the wind turbine, or the generator of the induction generator or synchronous generator of the wind turbine. So this is high speed side. So the shaft is connected to the gearbox to increase RPM, right? To increase RPM. Yes. So, so coming to the other set of questions, which of the following statement is correct about the wind turbine operating systems? So these are the options. So variable speed wind turbine is less efficient. No, this is not the right answer. Statement is correct about wind turbine of a power limitation strategy used in variable speed wind turbine due to thermal limitation of the generator, mechanical constraints of the wind turbine, limitation strategy, changing number of poles. Yes, B is correct. Due to the limitation strategy is variable wind turbine due to mechanical constraints on the wind turbine. It has certain constraints. It cannot go beyond them. So this is a numerical example. Numerical problems are not an example. any options. So let's solve it. So that C, yes, C is correct. C is correct. So C is correct. So let's solve it first. So P output is from the law. So here, if we fit in those values, the output will be 589.011. So values are given. Air density, this is rho, this is rho, then area. So pi into, since the blade radius is 5 meters, so this is pi r square. So this is r. So pi into r, we will get that. And the velocity, cutting speed, rated speed, and cutout speed. So considering the rated speed, considering the um, cutting speed, yes, for cutting speed. So cutting speed is 4. So this will be 4. This is 1.24. CP. What is CP? CP is given point the power coefficient. CP is 0.3. And efficiency of gearbox. Efficiency of gearbox is 70.7. And this is 0.90. 0.9. So area can be calculated. So A is equal to pi r square, where r is given as 5. So if we fit in these values, we will get this as one of the answers. 589. Now the rated speed. For rated speed, the problem remains same. Only the chain will be 25 here in the place of 4. Means v cube, means velocity cube, that will be 4. So this is cutting speed. So similarly, we can calculate for cutout, rated speed, P output rated, and this will be 143.801 and 495, and P output for cutout cutout speed. So that will be again 143.80, because both will be same. This is the plot, this is the initial part, then fixed part. So this is the 13, this is uh, rated, and somewhere this will be covered. So power remains same for both this rated and covered, right? So this is, so accordingly we have obtained. So this is the next question. Same problem we have solved in the initial case also, but the values were different. A series part. Yes. So, so same type of problem we have solved. So let's do it very fast. So since efficiency is given here, 80% of the rated, since each panel can generate 80% of the rated, so power each, so this is 30 into, so the remaining portion, now we have a total of requirement of 5.76 kilowatt load. So to suffice, to suffice this, the loading condition, so suffice, yes. So what we need to say is that 5760 is the watt divided by 24. So that would result in 4. So 2440. 240 panels. So total of 240 panels required. Now 240 volt is required, right? 240 volt is to be is the supply end, which load end value. So 240 volt and the rated voltage is 20 volt, right? So each panel can generate so 20 volts. So total of, so in parallel, if sorry, to develop the voltage, we may say mm, 240 volts. So each can generate 20 volts. So 12 40 divided by 20. So 12 panels. So 12 panels in series. So for the current to produce the required amount of current, which to require produce the required amount of power. So already we have calculated 240 total panels, and per line number of panels in series is 12. So that would result in 20 parallel paths. So the option is series path 12 panels, 20 parallel. So that's the right answer. 12 parallel paths and 12 panels in series. So, right. So this is the same to the previous question itself. Determine the power generated by the solar plant if the connection of one of the solar panels breaks open due to a fault in the arrangement in three. Okay, so you will need this. So one series is broken. So how much power will it produce? Or sorry. So if we can calculate how much power it can be reduced, so for the total power we have total power we can subtract and calculate. V 5470. Yes, V is correct. So that means total of total of, so one string if it is broken, so remaining 11 is in working condition. So previous we 240 volt and total power 240 I mean so total drop of you may say 20 volt, 57 yes. So 5475. So total initially uh, that power is required, 5 load power that needs to be delivered is 5.76 kilowatts. So 5760 watt is what is required minus one in one series there are 12 panels and each panel can generate 24. So that would result.
Sir, screen is not visible.
uh,
Screen is not visible.
3 is
Question screen only visible.
yes, from the question 3 itself, from this one, this 2.
Okay, okay.
This is a continuation of the previous question. So this was the total power that should have been delivered 5760 as per given. So this is 5.76 kilowatt. So but since one stream got somehow the connection got broken due to some fault that has to be considered here. So the remaining amount, the remaining value would be 5472. So this much amount of power will be delivered by the current system. So is it okay? So we can move on to the. So which of the following statements are correct in the context of distribution networks? This is an Which of the following statements are correct in the context of distribution? Yes, C is correct, and B, yes, B is also correct. Which of the following statements is correct based on the reliability of the microgrids as compared to conventional distribution systems? Uh, Option B is correct. Option A is not correct because microgrids are obviously developed to work for intermittent renewable energy resources, right? So they can't have lower reliability to operate with intermittent renewable resources. So they will have to have higher reliability considering these renewables. So this is wrong. Option A is wrong. So option B is correct because typically have higher reliability as they can operate independent during grid disturbances. So they can be isolated from the point of common coupling and accordingly the microgrids can independently work on the grid disturbances. So option B is correct. Option B is correct. So regarding real-time monitoring and control, which of the following statements distinguish the capabilities of smart grids from conventional grids? So this is again an MSQ type question. A and C. Conventional grids use outdated monitoring systems with limited data collection while smart grids deploys advanced sensors and communication technologies for real-time monitoring. And smart grids use advanced two-way communication for real-time monitoring and control, while conventional grids primarily use modern communication. Yes, A and C. Okay. So, which one of the following statements are correct about the difference between microgrid and the smart grid? So, these are the options. So a microgrid is a localized part of a distribution system that can operate independently or in grid connected mode. While as a smart grid is an extensive modernization of the entire electrical grid with advanced communication, control and monitoring technologies. So yes, option B is correct here. Okay. So that's it for today from my side. So if you have any questions, you can ask. And these were the questions that I tried to solve today, mostly theoretical as well as some numerical types. So, so with this, this is the last session of this course from my side. So, if you have any doubts, you may ask. All the best for your exams because you just have an exam.
Thank you, sir. In exam, most of the case, this our assignment questions and this discussion questions will come.
Yes, mostly the questions relevant to the assignments type of questions, numericals. 50% you can consider numericals and 50% theoretical part. So yes, both type of questions will come. So you can expect a mixture of both. And from same type of questions will make the numerical values will be different, but all the questions will be relevant to the assignments. So if you prepare your assignment questions very well, so you can get similar. You will get similar type of questions.
Yeah, method will be same. Method will be same.
Yes, yes.
Value will be different, but the method and structure will be same.
Method will be same. Method will be same. Values will be definitely different, but methods will be entirely same. Everything that has been discussed.
Oh, okay, thank you, sir. If you don't mind, can you send? Can you type your mobile number? If anything up in future, then we will contact you.
Yes,
Any
you can find by. Okay, you just send me a message in LinkedIn. I'll yeah.
LinkedIn? Okay, okay.
If you have any LinkedIn ID, otherwise you can share it there itself. This is an official platform, so we better to share there, right? This video
Yeah,
will
chat
be uploaded.
chat boxes is enough, sir.
Okay, then let me uh, switch off turn off the recording because